So this is the completed feedback ammeter circuit, and it uses the LM358 op amp right here, and it's kind of cool because it has two op amps on it, and I'm using one side to divide the voltage of this floating power source, which is just a battery, and I'm using that to then help with this ammeter circuit over on the other side. I also have another circuit kind of coming out of this to test the ammeter to make sure it's working properly. Oops. And right now it's reading 3.5 volts, and this battery's getting a little bit drained. So it's reading it over here, but this is actually going through a 1 kilo ohm resistor, and so the current is actually 3.5 milliohms, which is what this is reading. So just to test that out, I'm going to change this out. This is a 2.2 kilo ohm resistor, and it should change the value to about half. Yeah, so oops. Well, that's not right. Okay, so my setup wasn't that good. I had these too close together. Okay, that's right. And so this kind of thing probably happened a lot when we're making this, little mistakes and don't notice it right away. But yeah, so 1.72 milliamps is about correct for the 2.2 kilo ohm resistor. And yeah, the use of this is that with the microcontroller, you can read this voltage in, and there's plenty of reasons, that pop up that you need to know the current, and this can be pretty useful for reading that. So yeah, let's get started. Let's build this. So I already put the op amp on the breadboard here. It's important to remember that the rails are working. They're all connected horizontally, whereas in the middle they're connected vertically. So it's important to remember that when you're doing this. You don't want to bridge things accidentally. And also this median here divides the connection as well, so that these two sides are not connected. Alright, so the first thing that I need to do is bridge both sides of these, and I recommend you do that, especially if you're following this video, because you want the negative on this side to be the same as the negative on that side. Alright, the next part, I'm going to try to do this quickly, is we're going to divide the voltage of this source here when it goes into the first side of the op amp. And one thing that makes this op amp cool is that both sides have their own kind of separate operational amplifier, and they're both powered on the same IC or integrated circuit. Alright, so I'm going to put some of these. Now I'm going to power it on this side through this pin, and have the ground on the other side on the opposite pin. Alright, so the next part is I'm going to use a 1K ohm resistor to bridge these two pins, which are the negative side of this op amp and the output. And that's actually pretty important for I guess the degree that you want to measure. So I want to measure milliamps, so I'm going to use a 1K ohm resistor. If you want to measure nanoamps, you might use a 1 mega ohm resistor, and it goes the opposite direction too. Okay, so actually I'm going to move this one up a little bit and connect both the output with the Oh, that's not the output. The output's here. With the positive side of the other op amp. Well, on the other side of this op amp. And I also need to connect these two together because this one is going straight into that. Okay, so we finished this side and with these two 10K ohm resistors, and basically finished this other side too, but we need to know where to put in the external circuit, the one that we want to measure. So that should be, we need one wire going to there, we need the other wire going up here. Oh, did I get that backwards? No, that's right. I just need to figure out how to make these different wires. Okay, that's pretty good. Oh, no, actually I got that wrong. This one's right here. Okay. So on the positive side of this op amp, we have the negative wire, and on the negative side, we have the positive wire of the circuit that we want to put into this. So I'm going to grab a 1 kilo ohm resistor, put that here. We're going to also attach a battery, an external battery, so we can, kind of mimic a circuit that's coming from outside. And yeah, we need to power this with a floating power source, which is basically just another battery. And let's see what we got here. I'm going to check it with a digital multimeter. This is also important. Where we want to measure is on this wire and on the output. So the output's right here. Okay. So if you look at the schematics, it'll be a little bit more clear. And we have the milliamp current in voltage again. So hopefully that helped. Yeah, try it out, look at the schematics, and should be able to have a completed feedback ammeter circuit.